An absolute value, to just review briefly what it is, essentially makes a number positive. For instance, if I were to take the absolute value, that's what these two lines mean, the absolute value of positive 2 would be positive 2. But the absolute value of negative 2 would be positive 2. So a number that is negative becomes positive, and a number that is positive stays positive. That means that the absolute value of a number is a positive number. The absolute value parent function is defined as f of x, the function of x, is equal to the absolute value of x. So if x is 1, then the absolute value of 1 is 1. If x is negative 3, the absolute value of x is 3, so on and so forth. Now we want to look at the parent function first. And here we have a graph of the parent function. There are a couple of things that we want to note. The first is the vertex. Now the vertex is the lowest or highest point of an absolute value function. On the parent function, the vertex is at 0, 0, right in the origin. We're going to use that a lot when we start doing translations because we're going to begin with the origin. As we can see, from the vertex we have two lines going in opposite directions. On one side I have a line moving up and to the right, and on the other I have a line moving up and to the left. If we were to look at the slope of each of these lines individually, we would see that this line moves up 1 and over 1, which means that the slope of the right side, the right line of the parent function, is 1. And that is m. m equals 1. On the other side, if we were to do the same test, we would see that the slope of this left side moves down 1 and over 1, meaning that the slope of the left side of the parent function is negative 1. And that's the way the absolute value functions are all going to look. We're going to have one slope that's positive and one slope that's negative. When we're dealing with absolute value functions, we want to talk a lot about translations and transformations. I have a graph of a translation here. A translation moves the graph, but it does not change the size. As we can see in our picture, I have my parent function in red, going through with the vertex at the origin, two slopes, one of 1 and one of negative 1. And I have a new function. The new function has a vertex at 2, 1, the point 2, 1, and it still has slopes on either side of 1 and negative 1. Since the slopes didn't change, the graph is still the same shape. So we have not changed the shape of the graph, we've only changed its location. Now, the graph of the absolute value of x minus h plus k is the graph of the parent function y equals the absolute value of x, translated h units horizontally and k units vertically. So when we're looking at the equation of an absolute value function, we can tell how far it moves left and right by looking at h, and how far it moves up and down by looking at k. Now, in our example here, if I start from my vertex, which is where I always want to start, I can see that my graph moved up 2 and to the right 1. That means that my h value is 1 because it moved to the right 1. My k value is 2 because it moved up 2. That would make this equation y equals the absolute value of x minus 1 plus 2.